In this video, we'll take your first look at unsupervised learning. Unsupervised learning comes in many forms. There is clustering algorithms as well as dimensionality reduction. In this video, we'll specifically focus on clustering. Now, when we talk about clustering, the goal is to find collections of points that share similar characteristics. This is called unsupervised learning because we do not have any target variable. What we are trying to do is to discover patterns hidden in the data. So for example, we might have a situation where we have a two-dimensional data set described by variables x1 and x2 with a whole bunch of values, as you can see in this table over here. Now, of course, just given this table, you would not know which points share similar characteristics or which points share similar x1 and x2 values. Of course, because this is a two-dimensional data set, we would be able to plot x2 versus x1, and we can observe the data structure, and you can see that there is one cluster over here and another cluster down here, and finally we have a somewhat larger cluster of a lower density up over here. You can see that there are three clusters. This is easy to do when you have two dimensions, but if you have multiple dimensions, then this can be challenging. When I say multiple dimensions, I'm talking about more than 3 dimensions, something that you can't plot. And an example of such a data set might be something that looks like this data set over here, where I have one dimension acidity, volatile acidity, second dimension, third dimension citric acid, residual sugar, chlorides, sulfur dioxide, total sulfur dioxide density, pH, sulfates, and alcohol content. This data set describes roughly about close to 1600 different red wines, and each data point over here corresponds to one single wine with its corresponding characteristics. Now, of course, if you look at a data set like this, you would not have any idea about which wine is similar in its characteristics to which other wines. You would also not know if there are two groups in this data or if there are three groups in this data. There is no way to plot what is a 10 or 11 dimensional data set. So how do we go about identifying patterns in this data? Keep in mind that this is very different from supervised classification. In supervised classification, we would have another column for the classes which indicate which wines have similar characteristics. Here, we're in a process of discovery. We're trying to discover which wines belong together and are they different from other wines. We're trying to identify patterns in the data. We're trying to identify clusters in the data. Okay, so having said that, we'll examine this specific data set which relates to wine quality. And for that, we'll simply look at a Jupyter notebook, and I'll walk you through this specific Jupyter notebook, and we'll take a look at some of the other details associated with clustering at a later point in time. Right now, we'll simply take a look at the data and what exactly do clusters mean. So we're reading in our data set, and we are creating a matrix scatter plot of the input variables. I'm plotting fixed acidity, pH, sulfate content, alcohol content, residual sugar content, and density, and you can see the corresponding matrix scatter plot. Now, when you look at a data set like this, it does look like there's only one group of points, and you would be right. But if you also examine the data a little bit more closely, you can see that they're associated with a very large pH range, a very large range of acidity, a fairly large range of sulfate content and alcohol content, as well as sugar content and densities. And so the thing is, perhaps instead of dealing with this as just one group of points, we can break this data set up into 2 or 3 clusters, and each of the clusters would of course be restricted to a narrow range of alcohol content, sulfate content, sugar content, and density. So let's go ahead and do that. As with most machine learning algorithms, we scale our data. In this specific case, I'm using a min-max scaler, and I'm specifically using something called k-means, which is an algorithm for unsupervised clustering. I'm asking the algorithm to find 3 clusters. So we'll go ahead and find 3 clusters. At a later point in time, we'll see exactly how k-means works and what does it mean to choose 3 clusters versus 4 clusters or 6 clusters or anything else. But again, just to reiterate, I do not know, just visualizing this data set, I don't know where the 3 clusters or 4 clusters that I want to define are going to be located. So I'm going to go ahead and run this, and it's a fairly quick algorithm. Once that's done, we simply plot the entire data set, but this time around we colored the data points based on which cluster they belong to, and that's happening behind the scenes as we speak. And once this is over, we will get our plot, matrix scatter plot, with acidity, pH values, sulfate content, alcohol content, residual sugar content, and density. And of course, you can see 3 different wine types over here, colored blue, orange, and green. They're associated with wine type 0 for blue, 1 for orange, and 2 for green. So you can examine the properties of each and every wine type. But visually, at least, it looks like these green points are associated with, or rather share similar characteristics. They occupy a small region within the entire graph, and you can look at every single panel out of here. The greens occupy a specific region, the oranges occupy a specific region, and the blues occupy a specific region. And of course, depending on which way you view the data, you might see some overlap between the data points. Alternatively, if you turn the plot around and view it on 2 different other axes, you can see that the oranges and the blues and the greens separate out. And in some axes, the oranges, the greens, and the blues are completely distinct clusters. So you can see these 3 different clusters over here. If I were looking at this one panel out over here, which is density versus pH, you can say that the blue points are associated with high density values, low pH values, and the oranges are associated with low density and high pH, more acidity, and the green values, green dots, are associated with intermediate values of density and acidity. And this is all there is to clustering. What we had was an unstructured data set. We did not know which data points belong to which other data points. We just had an Excel spreadsheet with all the properties for the 1600 wines. And then what we did was we essentially clustered the data points together to form 3 clusters. Of course, we can form 4 clusters or 5 clusters or 6 clusters or 2 even. And how do we decide what's an optimal number of clusters is a topic for a later discussion. But for right now, you can see these clusters out over here. We could also look at the alcohol content associated with the different wine types, and I've created box plots so you can see that wine type 0 has a median alcohol content of roughly about 10, whereas wine type 1 has an alcohol content of 11.5, and wine type 2 has a median alcohol content of less than 10. We can also look at the sugar content within each one of them. And for sugar values, they're more or less the same, roughly around 2 to 2.5. So there aren't too many differences in terms of sugar content. But if you look at the acidity or the pH values, we can see that some of them are more acidic. That's wine type 0, and wine type 1 and wine type 2 are less acidic. So in that manner, we can not only look at the matrix scatter plots, but for each individual cluster or each individual wine type, we can examine what are their individual properties. And so this clustering out over here was done very, very easily. And of course, this kind of clustering can be done on many other unstructured data sets. Think about a collection of core data. You might have porosity, you might have permeability, you might have quartz content, you might have carbonate content, and you have all of these different measurements on maybe 600 or 700 samples. And just looking at the data set, you would not know which sample is similar to which other sample. You would also not know how many groups or facies or rock types are present within that entire data set. And so if we use unsupervised clustering, we can take that data set in, which is completely unstructured, and then provide some structure to the data. We can identify rock type 1, 2, and 3. Just like in this example, we've identified wine type 0, 1, and 2. And that essentially gives you your rock types. So in this case, you could get done with defining the clusters or defining the rock types very, very rapidly. And you can do a QA QC on that subsequently, as opposed to having a subject matter expert examine the data and spend lots of time trying to come up with groupings or facies. So that's one example where unsupervised clustering could be used. Another example would be with um, online retail shopping. If you're Amazon or Walmart or any one of the online retailers, you want to see what kinds of customers belong together, have similar purchasing habits and similar incomes and things like that. So you want to identify groups in amongst your customers. And if you identify those groups within your customers, then that's fantastic, because then for any specific group, based on their income level and purchasing habits, you can begin to start making recommendations about things they should potentially buy. And so this is heavily used in online retail shopping. It's used all the time for defining, for characterizing reservoirs, whether it be at the core scale or whether it be at the log scale or the seismic scale. You can also imagine that instead of dealing with properties like acidity and pH and sulfate content and alcohol content, I can feed in gamma ray logs, bulk density logs, neutron porosity logs, and any other log like the photoelectric factor, and do my unsupervised clustering. And what I'm going to end up with is maybe 3 or 4 clusters, which defines the electrophases at each given point. Electrophases are collections of points that share similar well-log values, things like gamma ray, bulk density, neutron porosity, and the photoelectric factor. And so with that, you can begin to start creating stratigraphic cross sections, because now you know how the facies are distributed from the top of the well to the bottom of the well. So this was a brief introduction to unsupervised clustering, specifically using this wine dataset.